I don't know. I think it's being blocked. Oh no, I'm going to try it one more time. Here we go. Boop, boop, bee, doo, boop, boop, boo, boo. Doesn't look like it's working. It says I'm live on the dashboard though, so I will trust that. There I am. I didn't really change any of the information in the restream, so you're going to get the same notification. I am just picking up where I left off earlier today. However, pretty big change in the works that I want to attempt. I actually made a new branch for this. Let me bring this up. So this is the issue I have now. Let me turn the fish on. Are the fish there? Yeah. It does say code generation by Walking AST. Damn it. I probably should have changed that video. Oh, well. I'll tell you right now, this isn't going to be about code generation by Walking AST. Even though I put that in the data for the title. I'm sorry. I'm so sorry. I didn't change this stuff. It was too much work. I did realize, though, that I have a couple hours to stream tonight. In addition to this, one of the people I mentor got sick. I hope they get better. And one of the things that I discovered tonight was I actually think there's probably a better approach. And this isn't a flip-flop. You know, if Mac were here, he'd be giving me a hard time. This is more of a growing pain. So I'm going to build on what we were doing before. Some time ago, when we first did this in the master branch, we made individual parse functions. So just so I can give you a sense of the evolution of where we are with this. And let me try to trace that really quick. So when we did our first batch, I'm going to go there now. We had these parser functions, and it's very traditional to make a parse function, and these functions are very limited in scope. All they do is parse the one thing that they know about, and they just advance the parser and return a node, or an error, depending on what they're going to do. At the same time, although it never got committed, it actually might need to commit it just for the sake of reference. We had an entire set of check functions, which were just scanning to see if something in the grammar matched the particular syntax. And this also included a set of is functions for classes, which are just very simple functions that would. This was kind of in the middle of the transition over to a struct. But what this did was it allowed us to. This was kind of an in between place. This was back when it was actually implemented as an interface, which we're going to come back to because I think that our functions are going to look more like this going forward. But back in that time, there's a lot of background history to give you. Oops, what's this? Oh, this was us doing our little test there. All right, let me see if I can find it. So there's master. What's this one? Exit on that. Where's my spec? Where's the spec? No spec. Where did the spec go? There it is. Okay. So here's the spec. Again, this is all about the pegn thing. You can go to pegn.dev and read about it if you care. But what the important thing to take away from this is that during the process of this, we kind of isolated these ideas of definitions, and all of the definitions we have like more significant definitions that are we call them scan defs or node defs. We have class definitions, which are just does it match this set of runes or this set of Unicode code points, and then we have tokens, which are either strings or individual Unicode code points. So when we did that, the first version of this had them all spread out, and we had them as kind of separate ideas, and that was fine, and that got us our first parser, and that's great. But then I realized if we were going to do this well, we were going to eventually have to map the really fast numeric AST to more information. And actually, that whole issue came out when we were trying to do error reporting, exhaustive error reporting when somebody got an error and they were trying to submit, a peg grammar that didn't match. And so I wanted to give them, very good error messages. And in fact, the first iteration of this is we wanted to have something they could read, and so we actually added names to the numbers, and I'm glad we did that for the reasons I talked about before. But then we still have this other issue remaining where we needed to get more information about the errors to the end user who's using the product, and whatever, who's parsing the thing. And we started to see a little bit of this in the is functions. So the is functions were the first ones that I was debugging, and I was like, man, when we get this error, I want to be able to have some sort of verbose description when they get to the error, so it's a nice healthy description to give people. And that was all well and good, but the problem was the struggle to see, okay, well, how do we communicate this additional information when it's not included? We have to parse it from this grammar, right? And that dates back even further to an early design decision not to include one-line descriptions and things like that within the specification grammar, the pegn syntax itself, so that it doesn't get overwhelmed with too much rhetorical information, stuff like that. So the decision early on, I made a decision to put that kind of information in a README file that could then be pulled out of here, depending on the match, and give really great documentation for a particular grammar. So that means in order to the formal specification of any grammar would include the grammar file, the pegn file, and would include an optional README file that would have more verbose descriptions of that, what it is, how it parses it, and everything. And that would be at the top level for people who want to define like rather formal large grammars, so that any language, anything that has a structure could be captured, including, and we did that. We tested it with JSON and YAML and some things to express them as pegn. So that's all well and good. But that means, so in order to understand everything about a particular grammar, you'd have to have the grammar file and the README. All right, so that's for formal grammars. And then during the whole process, it became obvious that the whole thing could be used for regular expression replacement as well, and that's where we got a lot of this dynamic stuff. And I think that was a little bit premature, and we're kind of backing up on that. But the question as to what is the most performant and easy to sustain way to include description information in the representation of the grammar, and part of that evolution became the move to putting definitions, just like having everything is just a definition, and that has been where we have been. And rather than doing them all and having to redo them all again, I just did 2 or 3 of these definitions, and I included a scan function as a first class function within a struct. And these are all variables, which I'll get to in a second. I'm thinking about dropping that. And then having a parse function. So we have a scanner and a parser so that they don't have unnecessary work. And I only did a couple of them because I'm testing what this is going to look like when it's built out. And so that's actually what triggered this. So I actually got quite a ways into writing the generator this tonight, and not on stream, but I was working on that. And it became clear that we're going to need to have, this is what happened. I started loading the AST, and so we kind of got combined. And I realized I had to start populating the definitions table. And then I was thinking, okay, well, one of the reasons I moved away from doing these kind of singletons, which are, implement like an is function like I was doing, and then having one of them, be together, was because I wanted the structs to be really fast, and also didn't, I wanted to be able to refer to them from a definitions table, so that when we walk through the node tree, the AST, that or we can look up the number and look it up in the table, and then match it really quickly to its parse function, and to its its description and stuff, depending on what we want to do with the AST. So it occurred to me very recently that we're going to have to have that reference anyway, So, this is, always been a little bit hesitant to have variables in here like this, but the thing that really sealed the deal for me was when I remembered actually that any variables that are defined in this way are automatically included within the documentation. So, and I've gone back and forth about whether this should be private or not, all of these things. And that has been part of this decision. But as you can see here, we have a Go doc that has all the constants, and then it has has all the node types, and I mean that's kind of okay. That one, looking at that one, but does it need to be there? Is this going to be? Are we going to make it public? This is all code that's going to eventually be generated, and at one point it had underscores in front of all of it, so it wouldn't show up in the docs. But this, whether or not we decide to make it public, is a different question from whether or not we want these definitions to be the only one. And I feel initially like that was a good idea, but what I'm exploring, and I haven't made a decision yet, but what I'm exploring is the possibility of just making it an interface. And here's why. Because the reason I kept with the struct was from performance. Again, this whole secondary refactor has been mostly for performance, without throwing away readability, and that's what this is, right? So we went to Booleans for the scans, so we can build scan paths and be really readable without losing a lot of performance. These are extra indirection, they're extra function calls, but they're they're not expensive function calls in the overall scheme of things, because they're able to be read, and we don't get the crazy output that comes from other code generators that is completely and totally dependent on the generator from that time on. So that is one advantage of where Pegn is going, is that the code that gets generated by Pegn is maintainable and can be used as is if it's just a one-time generation, or you can even make our generator have a configuration file that says, okay, these three particular definitions, don't touch them, because they have extra code that needs to be done that can't be represented in the grammar by itself. And that's particularly important because in our grammar, we do not allow the inclusion of any code, and we never will. It's a bad idea. Every other Pegn parser does that. A Peg parser does it, but I think it's a horrible idea because it makes your Peg grammar is completely and totally dependent on a specific language. So, having gone through all of that, that's kind of just getting us up to speed. The question before me is, and I actually created a branch for this, is what would this defs file look like if I had done it as an interface? If I had created made definition into an interface and done it that way. And the tough part about that is what it would look like. As soon as you say interface, now you're talking about an extra function call, right? Well, the only reason I'm even entertaining this possibility is because, one, we have to have a reference to it in the lookups definitions table anyway. So we have to create one of these things, even if it doesn't have a name. It can be referred to by number in the table. We don't even have to have a name. We can just use a total symbol lookup table, and that's kind of where we're going with this. And two, there's nothing wrong with having a struct that implements the interface, in this case the scan and parse functions methods, but also allows public access to the structs within it. So if we do that, then we can reliably pass definition around to everything as a type, but I don't know if that's going to render us, I don't want to worry about it too much, but I don't want to put us out of the running for a C port later that's going to be nice and easy to understand. So I would kind of rather keep a struct like this. It's just very easy to do in C, but it would be a definition. Another possibility would be to just hard code the symbol table, and then that's the end of it. If we do that, then the table itself would remain invisible to everything else. We could make it just kind of internal, and that would that would be fine. One of the negative side effects of that is we would lose the ability to have documentation, like code documentation of any particular thing. So pretend, for example, I had if I were to change this octal here, and I was to say, okay, I want to make that into a type octal is a struct, right? Well, so that's the kind of thing we're talking about. And actually, we could probably do this. I mean, this is the real question. I need to play around with this. What would it look like, and what would be the implications? If we do it as a struct, then that leaves lots of opportunity to document the struct. And since all of this stuff is being generated by code anyway, in case of Go, that would be generating automatic API documentation as well as what's already available in the README and other places. So that has value to me, because it's like, if I just make these all headless structs, anonymous structs that are assigned to the symbol table, the defs table, by number, and then looked up through reverse lookup, that's all well and good, but that completely negates the opportunity for me to do any code documentation, and that gets a little tricky, right? Because it's like, how much of this code do I want to show up in the Godocs API, the Godocs repository, and how much of it do I just want to have them go look at the README file and look at the grammar that way? I tend to think of the second. The one thing is for sure is that anything that's public has to be documented, or you get lower grades on your code quality and all that stuff. And since we already are deriving all of this stuff like pegn and stuff, we could actually have that information be available as documenting a particular struct that implements a specific interface, and we'd have to, as long as that thing is public, and then that makes the decision to somebody who wants to do code generation, say, look, do you want to make your grammar, the elements of your grammar, do you want to make it public so that you can document it and read the docs and go, or do you want to have it not be documented at all and have people just look for the documentation in the README for the grammar itself? There are lots of cases. There's lots of stuff going both directions. I imagine we're not going to get a lot of input tonight from the regular peanut gallery, because I am doing this at night. This is a very odd time for me. This is normally something I would do during the day. And so I'm left with these questions before me. And honestly, these are the kind of things that you can't answer in advance. You kind of have to just test out one way and then test out another way, and then kind of decide which one is better between the two for the longevity of the project and every other project. But given the scope of this, at least for my code, and also potentially other people's code, that the code that's being generated with pegn will live, for years. And these are important decisions, because this isn't just a decision about what my code looks like. This is a decision about what everybody's code is going to look like that's generated from this. And that means that I have to be able to be really solid and able to prove to everyone else that this is a solid code approach, and explain why I made this performance trade-off for the clarity of the code, et cetera, et cetera. Particularly if I'm going to do anything like present at GopherCon or something like that, which I do hope to do, be able to do someday. So these are important decisions, and I can tell you right now that making these individual structs with anonymous function assignments is going to look dubious to anybody who comes to Go. I did that strictly for the performance advantage, and I feel like it is probably the wrong choice. So I'm going to go test this right now. So let's take the first one and change it. So again, this is a new branch, in case you're wondering. The PegX branch is now published. I hadn't published it earlier, so if you want to go see that one, you can. Master has our original code in it, and yeah. So I want to explore what all of this is going to look like by implementing each of the types, the definitions, as an implementation of a definition interface. But without the overhead of the calls. And this this is a place where, encapsulation, OP, purists are going to really freak out, because I'm going to be straddling the bridge of encapsulation versus performance. And see people would be, would be, critiquing it from one angle, and then you have like OOP Java and C++ people critiquing from the other side. And so suffice it to say, because I don't know, let me think about this for a second. Even look, I don't care if it's not completely able to be written in C, but that's that. What would that look like? I don't want to go down to that road too much right now. So there's two things I want to try out. I want to try out, what does this look like? This is what it looks like as a struct, but what does this look like as, what does this look like as a type? So ocdig is an actual type that has, that has these methods hanging off of it that have been implemented specifically. Another reason for doing this too, I want to just bring up as I remembered, is it's becoming clear to me also that the long form that I kind of allowed, I was really stickler with the long form. I really don't want people to ever depend on the long form. I want them to use the short form for 90% of the work they do to combine ASTs together and everything. This is really where the work happens. But long form is fine. It's usable. And this got me to thinking about another possibility, and that is quite simply defining a definition as having more to it. And this is very easy to read right now. You can kind of get a sense of it, of what the structure of your thing is. I don't really want to mess with it, but it did occur to me that I could have optional extra fields in here that are documentation. Let's stop using Google. Agreed. And so that's actually one way to do that. I'm definitely a Firefox guy. And so yeah, we've got a lot going on here. I don't think I want to mess with the long form of AST. I think that's important to keep that there. I want to keep as much of the documentation out of the JSON file and in a separate file. So, perhaps I would have, and actually this is a good thing to note, perhaps we could have an additional JSON file that goes with the AST called AST dash, descriptions or whatever. And what that would be the, or whatever. It would basically, we need another, no, it should probably be defs.json. Actually, that's what we should do. Yeah, that's what we should do. And we should have defs.json. And then what that would be is that would contain all of this information here, right? And the defs.json file could be extracted from the markdown file, but be in a much easier to parse way so that those things can be combined together when we're doing code generation. They would be kind of created dynamically when we're doing dynamic code generation, but they could be available to bring together in a way that allows you to document your grammar very well. So I'm glad I thought of that, but that's another tangent I don't want to go down right now. So back to this. What does this look like? The first thing we're going to break is we're going to change the definition type. So, and that is going to break everything. So we're going to say, here I have a definition type, but now this is interesting because, I'm not going to do any subclassing or that crap. But we could do this instead of it being a struct. We can have, rather than have a type of struct, we'll make definition an interface. And then it just will so happen that all of the things that do it can have, we'll have these fields. I wish to high heaven that, that you could have, I think you can with an embed. Let's do that. So let's do this. Let's change definition to, we'll say, definition info, I guess. Def type, def string. Let's see if we can do this. We might be able to combine an embed with an interface. and do it that way. So yeah, let me think about this for a second. So we could do def info, and this is important. We could get rid of these two, and then we could do type definition. It could be an interface with the following methods, and with a scan method, and then it's not anonymous anymore. So, and then we change it like that. Obviously, it broke a lot of stuff. So then we have definition, we have interface. So then what we could do is when we make our individual thing, we do our code generation, we can change it to be like, you know, hi El Ramingo, good to see you. Then we could actually do this. We could actually maybe follow a convention where, well, that's interesting. Why do we have a string on that? Is that even possible? I don't think it is. I don't think we can have a stringer off of an interface. That doesn't make any sense at all. These things would have to be. Oh, that's tough. Huh. Actually, no. I can hang these off of def info. Yeah, this is working. This is gonna work. I see my recent enemy. What are you talking about? Go or something else? Somebody here. Interfaces. Yeah. Yep. Yeah, I love it. But so here we go. We're going to do this. And then we have a definition. So I'm going to do definition. Here is an interface that implements scan and parse. And it has an info struct. And then we will have we'll automatically implement the stringer interface so that it can be printed, and that will just print the information about it without the other stuff. That's perfect. That's perfect. Okay, so this gives us enough to build with. It also has a def type in it, so we can, you know, they can identify which type of definition it is. All right, so let's do that. Let's say we're going to have a lot of things break here, but that's okay. So if I go back to my defs now, I should probably just disable defs test for now. It's going to complain like crazy. Let's see. The defs test would be auto-generated too, by the way. So I'll turn that off for now. Defs.go is going to have to change. And this is now a struct, right? So yeah, we could have I'm just thinking here. No, that's right. So right now what we could do, I'm a little bit torn here and trying to decide, because right now we have these by-ends here and we have these things here. Again, this is going to be generated in any package, so that it potentially would have naming conflicts. So I got to figure this out. This would build in an oct. So if I want to have an octdig, that would be, I could have pegn octdig. I could do octdig def. I probably, just for the sake of the documentation, I should probably do def, the definition of an octdig. Does that make sense? That's just so that everything pulls up next to each other. Otherwise, it's going to be really annoying. Now, I've thought about putting this all in its own package as well, but I think that's pretty fair to put the pegn def octdig def. If I put octdig def, it won't be grouped together. Or I could just leave it off and say it's a pegn octdig. Well, what's an octdig, you know? And so, I mean, in the case of this particular package, I kind of like them having the top level visibility, because it'll it'll help you document it right away, and that's the whole point of doing the documentation this way. So let's take on one of these easy ones. So ocdig is a scan, so its parse function is not even going to be very significant. It's just going to return nil. But this is how we would do it. We do type ocdig is a struct. Struct, and this it's a struct that implements that has a it has a def info, and it implements definition. So that's all we have to do for that, and then this stuff we can redo. In fact, let's get rid of all of this so we can get stuff to start passing. The node types are going to have to stay. That's all that stuff has to stay. Def.scan undefined. Scanner.172. Yep. Okay. So the scanner is clearly going to have to change a little bit, and that's fine. So what? So we have one of these structs. Now this is going to be interesting because we need to make one, and we need to put it in the definitions table for a given expression. And in this package case, we have a definitions table that comes with it. So I almost think that rather than have node types, we should have a pegn.definitions file, like not a file, like a lookup table, and add those to it. Because I mean, see, the hard part about having it be a struct like this is that I then have to do the assignment and create like a singleton, and that's why I stopped doing this last time, because I can define them like this, right? But yeah, because how and we'd have to have assignment going on. We can't. This doesn't require assignment because it takes place at compilation time. I don't want assignment happening anywhere in this code at runtime. And if we do it like this, it is runtime. The only other way to do that would be, well, let's pretend like we have a table that has all of these things in it. Yeah, I don't know, man. I don't know if I like that. Because, because we can't hard code the initial things because there's no constructor or anything. I mean, that might be one thing we could do is like force it to have a constructor or an init or something. We could do, you know what I mean? We could do, I'm trying to think what that would look like. So that would be, let's go back into the devs test. We do something like this. We could do example, parse octal. And I mean, if we did this, it would be something like this. It would be like octal. Wait, pegn dot octal dot new, and that would give me a new octal value. The interesting thing about this is I could actually have state associated with each one, so that I could instantiate them at real runtime when needed, but most of the time we're not going to need that. That would be wasteful, way wasteful. And if we do that, let me think. I mean, we definitely could do that. That would be okay. The problem with that is, at the very least, that initialization is going to have to happen at startup. And I think I'm talking myself out of this. I really am, because there are so many levels of indirection to get this to work right, because it's all runtime stuff. So the reason that this works so well is because Go allows, this is runtime. This is runtime. So let me think about that for a second. This is runtime. It does the var equals. So that assignment happens at runtime. That doesn't get compiled in. And so I need to think about that. I mean, I don't know how different that is from a .new. A new would be a function call, which would be setting all these same assignment things. But this would happen way before main happens. It happens way before init even happens. The only problem right now is that this is like marginally annoying because it's being listed in the documentation output. Also, it forces you to look at the README for the documentation as opposed, because this is generated from the README directly, rather than look at the Golang documentation. So I don't know. The fact that I have to both define the struct, I have to do a bunch of these, right? And then I would have to implement the new interfaces for them to be able to have them work properly. And then that's like 2 levels of indirection just to get this. Doesn't make any sense at all. And frankly, this particular project is the only one that really want these things to be public. Most projects that are going to do grammar creation are going to want all this stuff to be invisible, and they're going to want one entry function to the whole thing. They're not going to want all their namespace being polluted with a bunch of these grammar definitions. They're going to want those to just be tucked away, kind of nice. So this little that really did it for me right there. I think I'm done, because this is I have to do this in order to assign it. Either that, or I'd have to. Well, I can't actually. I'd have to put in a init. I'd have to put in a init function in here to actually add the values for an octdig. So it's not like you can just subclass it and have the, because why? Because you cannot do. This is yet again another way I've been ruined by OP, because this is a case where I would use static properties or class properties, and they would be initialized from the beginning of the thing, and I could define them as a part of the class. But that is not possible when doing Go, because this isn't object-oriented programming. So if that is an OOP construct that's stuck in my brain that could not be done here, and frankly doesn't get us any farther along. It would be really slow to do that. So that does force me to think in a C-like manner, which is what this is. And this will very cleanly and quickly port over to C, which makes me even more happier. So I'm glad I talked about this. This is pretty much a rubber duck situation going on. But maybe you've learned something in my kind of, floundering along in it. I'm going to go back to my other branch and throw this branch away at this point. I'm going to grab some coffee and think about it for a second. But I'm at this point, I do not feel like building a struct just to have one of those structs initialized and put into a table is worth it. Now, I'm still going to have to put this entry into the table somehow, and that is going to have to happen in an init function. But I still think that's going to be way more efficient than, because they will have already been defined before they even get to the init function. So I talked about that before. The order of operations when things are running, the first thing that happens is all the assignments. Constants, of course, are embedded. I'm going to go read about that again. So Golang order of init and variable assignment. So it's actually declaration. It's not assignment. And that's important that you get that distinction. I talked about this last night. Declaration within is allows us for assignment at the same time. If you try to do anything fancy though, it will say no, that's a declaration, you can't do it. Data types and variables and Go. So let's talk about this for a second. So all of this is possible. So declaring a variable. All right. So you can declare a variable and give it an initial value. To declare a single value, you can do the following syntax: initial value. The problem, see this initial value thing, if this is anything that has to run, it won't work. Now the question I have before me is, does Go optimize this, or is this value assignment? Does that happen at compilation time, so the code includes the initial value before it even gets executed, or does it just like really optimize it so that when it runs, that value gets assigned? Because I know for a fact that init runs after that at runtime. So the question I really have is what kind of hit am I taking through this variable assignment for the initial value? It says initial value is optional. If you do not give initial value, the variable assignment will hold a zero value. See, this is what I'm talking about. So zero values, I have a feeling, are assigned at compilation time. So what that means is that the thing is compiled with the zero value in it, and that the zero value is not assigned at runtime. It's assigned at compile time. And so that's why you can have an initial value, but it's also why it has to be simple and it can't execute any code. Because if it has to execute any code, that would put it in runtime. So my inclination, I want to read the words myself, but my inclination is to think that initial values that are assigned to variables are actually embedded in the compiled code. And so they don't incur any runtime penalty whatsoever. If that's true, then the making this definition here just means I'm going to have to mess with this being like hidden, right? But this declaration, because this is all static, this declaration with its initial value would embed all this wonderful stuff inside of the compiled binary, which would save me a bunch of runtime hit that I already know I would have to hit in order to initialize this, this awkdig with stuff that's going to be there, either at init or at main. Those are the two follow-up runtime execution phases. So yeah, let me just read some more on this. I'm going to go get some coffee. I'll be right back. All right, I'm gonna go, just while I'm drinking this, I'm gonna go check in with our YouTubers, only because I had a YouTuber actually chime in and answer one of my questions, and I forgot to check it. And I was like, so anyway, I was very frustrated by that because I found it later. I was like, oh, I wish I could have showed him. So I don't have anything here going on. Man, I've already been doing this 43 minutes. That's fine. This, as long as this saves me time long term, which it definitely will. I'm assuming sound is working. Sound working? Definitely will. Is sound working? Check 1 2. I'm assuming sound is working. Sound working? I assume it is. Is it working? Check sound check. Working? Check 1 2. Maybe not. I don't know. I can't. Normally I could hear sound there. So I'm just curious. So if even if the sound doesn't work, at least I figured out all the questions I have. So let me keep going with this. Okay, default is false. You can later assign or reassign any value to a variable. You must follow the syntax to reassign. New values to predefined variables. That's interesting. Okay, so let's go from here. Variable name convention, go blah, 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 camel case, simple or camel case, even underscore variable names are valid. Yeah, they are not idiomatic. Who cares? Type, let's see, type inference. Yes, got that. Go one further type, got that. Declaring a variable with initial value, got that. Shorthand notation, yes, it's walrus notation, but it's only in block scope. They didn't specify that. That doesn't help. And go perform address. This is not going to answer my question. I'll tell you right now. If you have, you know what? I wish I could find it. There's like a really, really esoteric explanation of a init and when it runs, and it specifies when declaration happens too. I could swear to God it said that declaration happens at runtime, variable declaration. And I want to be, I hope it's wrong. I hope that memory of mine is wrong. All right, no. Multiple constants can be declared. Fine. Iota, yes, got it. Numeric expressions, don't care. That is not it. Declaring variables in Go. And let's see, variable declaration in a init no, that's dumb. I think the important thing is the go init function. I think that's the one we're going to have to read about. Order of initialization. This is a big common question. It's pretty obvious. It's just lexicographical based on the file, and so you can never trust anything concurrent to be in any init function. The init function is a special function that any file can have in it that will be run before main can run. So that's what that's about. And those are gathered together. Okay, so the problem is this is all the code inside of here runs at runtime, and I want to save that hit. So yeah, in this example, we can start by using the init function, multiple inits. Here we go. Say imagine for main broker database, specify an init, blah, blah, blah. You cannot rely on the order of execution of init, even though we know what order that is. Order of initialization for more complex systems, more than one, blah, blah, blah. When it comes to our note, more in-depth overview, blah, blah, blah. Lexicographic, yep. Got that. Don't need that. Come on, answer my question. In this scenario, nope. Multiple init functions in the same file. Yes, you can do that. That's kind of cool. But lame. People do that because it's easy to read. Respective, yeah. So it's not that much extra overhead, but that didn't help me. There's the specification. Okay. Here we go. Here we go right here. I am actually streaming.
You're supposed to walk to the
I know. It's 9 o'clock. It is. Go out. She needs to go out. She was scratching at the door.
At my door.
Okay. Let me figure this out, and then we'll go for a walk. I'll come back and stream some more. Let me fix. Okay. The byte order mark. No. Bleh. That's not what we're looking for. Whereas, you know what? It's funny because it's always answered in the spec. Can I just say how good the spec is? The Golang spec itself is. Unlike regular variable declarations, a short variable declaration may redeclare variables provided short variable declarations may appear only inside functions. Oh, that's not what we're talking about. The init function in Golang, order of init functions. No. Let me go see the spec. Let's go see if the spec has it in here. Let's do shortcode representation, a variable declaration. And type constant has a default type with no explicit type. The default type of untyped constant is Boolean, rune, blah, blah, blah. Implementation restrictions, a low numeric constant, nope. Variables. A variable is a storage, blah. Function declaration for function literal versus storage, nope. Composite, literal is bad, don't do it. Structure variables, yes. Static type, dynamic type, assignable. Order of assignment, that's what I want to know. A type determines a set of values together with separation. Yes, got that. Got all of that. String types we need to look up assignment or declaration. A field declared. Nope. Declaration will be followed by optional string literal tag. Ugh, don't use that. The reflection is really slow. Let's see. The method set of T is a union of blah. Nope. Given the declarations, let's see. Two maps have identical key maps. Yep. Nope. Pre-declared identifier at the pointer. I think it talks about it in the init with the init function. Okay, where is it? The identifier init may only be used for init function declarations. Like the blank identifier does not include a new binding. The scope of a declared identifier is the extent of scope. Source text in which identifier denotes a specific constant. The scope of a pre-declared identifier is a universal block. Okay. Go is lexically scoped using blocks. Scope of a pre-declared identifier is a universal block. Okay. Scope of an identifier denoted a constant type, variable, or function, but not a method declared at top level outside of function, is the package block. Okay. Pre-declared identifier. Interesting. I wasn't sure I didn't know there was pre-declared identifiers. Oh, I get it. No, pre-declared identifiers are things like map and main and stuff. Okay, so the scope of the package name of an imported package is the file block. Got it. Package name of an imported package is the file block and the file containing the import declaration. Okay. Scope of the identifier denoted. Okay. Scope of constant. Scope of a type identifier declared inside a function. Yeah, which you can do. You can't declare functions inside of functions. They have to be declared outside. Otherwise you have to do first class function assignment. An identifier declared in a block may be redeclared in an inner block and cover up. Yeah, it doesn't have to have global. Python. The package clause is not a declaration. Labels are declared by labeled statements. Yes, yes, yes. Blank identifier. No. Pre-declared identifiers are. There they are. Types, constants, zero value functions. Export. Man, this is so well written. You guys did a great job. Go people. Constant expressions. Are you already ready? They're showing me. She's got her headlamp on. All right, people. I'm going to come back. If somebody wants to work on this question for me until I come back, I'm going to go kill the stream, by the way, so I can update the title. But the goal here is to minimize the runtime of the generated code that defines a declaration. I mean, sorry, that declares a definition. I know that sounds weird, and if you've been following this project, you know what I'm talking about. Specifically, what I'm setting out to find out is if the variable declaration in the package scope with its initial value assignment happens at runtime, or if that's built into the compiled binary. So if you have the answer to that, let me know. And